Hi everyone, thank you so much for joining us today for this exciting talk. I am your host Ajit Singh Rana. Today I have with me a special guest, Sonia Mehta. She is a data scientist and ML engineer from EXL. Today we'll be talking about our latest blog post that we collaborated on, rightly called as How to Develop and Deploy a Customer Churn Prediction Model using Streamlit and Docker. We'll also look at the complete demo around this solution during the talk. Okay, to start with, let me talk about myself. I work for Docker. I have been part of Docker Captains program for the last 6 years. I am a Docker Bangalore community leader and I have been leading community of around 11,000 members. Do check out my personal website where I have around hundreds of blogs which I have written on Docker, Kubernetes, and cloud. In the past, I worked for companies like Redis, Dell EMC, VMware, and CGI. Over to you, Sonia.
Thank you, Ajit, and hello to everyone watching. I'm Sonia, and I'm currently working at EXL Health, helping my team build an end-to-end data science workbench that helps you train and deploy your models seamlessly. And I'm also working with technologies like computer vision and NLP and embedding these into our existing products. I've been an active speaker in the field of AI and MLOps, and previously I worked at Nestle, Savant Degrees, and Freshworks. Here's my LinkedIn handle. I'll be happy to connect with you, and that's all about me, Ajit. Back to you.
Okay, so before we dive into a complete solution, let us spend some time and understand what is customer churn and why it is important to understand the term. The customer churn is the percentage of customers who stopped using your company product or services during a certain time frame. It is also called as customer attrition. Now, the now you might be thinking about why do customer churn happen, right? What is the reason? There could be a number of reasons for this. The first common reason is pricing. Definitely, the higher the price, there are chances that your customer might churn. The second is product. If your product isn't living up to the expectation, or if the promised features aren't being delivered, the customer might churn. The third one is poor experience. If the customer cites a poor experience, then that would be the time when you really have to rethink your internal customer success strategies, right? There are other reasons like lack of value, competitions. These are other factors which can lead to the customer churn. Now, the best analogy to understand the customer churn could be the leaky bucket theory, right? Now, the leaky bucket is basically a marketing theory. It is simple. It suggests that the organization are always losing customers like water dripping from a leaky bucket. Now, to keep that market share, you have to continuously bring in the new customer to replace the customer you are losing, right? Now, this keeps the bucket full, or at least it slows the leak. Okay, so now let's talk about how to solve this customer churn problem. Now, one of the most effective way to reduce this customer churn is know your customer. You have to educate your customer. You have to provide them with enough good quality educational or support material, right? Which could increase the retention and reduce the churn. You should offer them a free training, webinars, videos, and product demos, right? Whatever it takes to make your customer feel comfortable. Now, let's stress it once again. You have to simply find out why your customer decided to leave. Now, for starters, you need to provide the ample and versatile content, right? Which talks about the key functional benefits of your product. You need to offer them the regular news update, upgrade, special of offers. And then another way to prevent churn could be actively engaging your customer with your product. So the best way to predict behavior is to retain the customer is to know the customer, and to know the customer, the best way is to look for the patterns in historical data, and that's where your machine learning comes into the picture. So, for example, the marketing department in your company can use a churn prediction model to filter the high risk customers and then send out the promotional content to entice them to stay, right? Now, in order to really go ahead and solve this problem, we tried looking at what could be the ways, and we try to put it in a form of a kind of a list of things. The first thing is you really need to go ahead and train an ML model, and this could be by using a classification algorithm, right? which predicts the customer risk of churning. Then we need to apply machine learning to customer data, which can help companies develop focused customer retention program. Then we need to come up with, we need to use some kind of very robust technologies like Streamlit, which is basically our application framework, which helps you to build a UI component and package our model. And at the end, we need to have solutions like Docker, which helps you to go ahead and publish your model as an endpoint. Now, to understand all this, I would like to hand it over to Sonia. She is going to take you to the journey where we went ahead, we built the ML model from the scratch, and how we use Docker container to go ahead and publish our model. Now, over to you, Sonia.
Okay, so let me just throw some light on on some of the steps that we've taken to build our customer churn prediction model. So we have used the logistic regression algorithm from the scikit-learn library. So logistic regression is basically a classification algorithm that learns from your historical data. It calculates the best coefficients for each of the features that you've passed into the model, and predicts the customer churn probability. Basically, it gives you a score between 0 to 1 for the new incoming data. All right. So there have been a lot of steps that have been taken before even the model was trained, and we've used libraries like NumPy, Pandas, and Matplotlib to visualize and fine-tune our data set. So we basically used historical customer data of a telecom company, and then we have passed it into a logistic regression algorithm, tuned it with certain hyperparameters, and tested it against the new customers to see how well the model is performing. And if you are interested to check out the step-by-step flow of this entire model and how it was created, do clone the Docker samples GitHub repository into your environment and check out the 2 notebooks that have been mentioned at the top of the slide here. So now let's say we've built a model and we have it ready in our Jupyter notebook environment. How do we make it useful for our end business users? How do we give these prediction score output results at the right time to the right users so that they can trigger certain retention strategies to get our high risk customers and stop them from leaving the company, right? So we need to deploy this model into production. And before we are able to do that, one of the key steps involved here is to save our machine learning model. Now, this is important because we need to ensure that our model is able to run on any environment and it's portable and reusable. And for that, we have to figure out a mechanism that could save the coefficients, the hyperparameters that were calculated during training, and the encoding logic that we've used to transform our data and put and package all of it together. In our case, because ours is a scikit-learn framework model, I've used Pickle, which is a standard serialization library from Python, and I've used that to save our logistic regression model, as well as the dictionary vectorizer, which is a one-hot encoding algorithm. And once I saved it, and you could see the code snippet here, I've used pickle.dump function, which allows you to which basically serializes a Python object. And once we have that binary file saved with us, now we could load it in our application anywhere and call our model to predict on new incoming data. So once we have this piece up and running and set, and once we have our model saved, now we have to think about how do we make our model useful, right? And one of the ways to put our model into production is by exposing it as a web service. So a web service is basically like a communication protocol wherein it would listen to requests on a particular port, and it would take in those requests, um, um, transform the data that has been sent over the request, put it inside our machine learning model, get the predictions out, and return it back to the end user. And we could obviously deploy this as a REST API, but to make things more interesting and interactive and visual, we could write a front end to our application and create a super fun UI on top of our web service. Now, there are certain Python frameworks available like Flask and Django that help you develop web apps. But recently, there has been a shake in the machine learning world with a new technology a framework called Streamlit. And we'll be using that to write our web UI, and to basically not just write a front end but also integrate a back end through very simple and minimal script. And this is how our application architecture would actually look like. So we would take our model, and we have already saved it, and then we're going to wrap it with the Streamlit's application components. So Streamlit is going to take care of rendering the UI and also triggering the backend logic. And once we've written the application, we are going to take the dependencies, we're going to take the model and the code, and of course the Streamlit application script that we've written, and containerize all of it as a Docker container, right, using Docker. And this is going to be published on a as an endpoint on a port, and which would be accessible to end users. They could just call the endpoint, interact with the UI given the data of the customer, and get the risk of churn in return from the web service, right? And that could then be used by the business to trigger their retention strategies. Now, you must be interested to know why Streamlit. Now, Streamlit, to be very frank, the one of the biggest reasons why it is so popular among the machine learning community is because it removes the barrier of having to know front end frameworks like HTML, CSS, and JavaScript. So now anyone can create these interactive web applications to showcase their ML models and display their data as charts, and add in all these powerful widgets into their application without having to know how to write a front end and how to connect it with the back end and define routes and HTTP requests and all of that. And with just minimal Streamlit API, you could just use that in your existing Python script, model script. Basically, you just have to write few lines of code, and you would have a beautiful dashboard kind of a web app up and running. And you would just see in a few seconds, I mean a few minutes, how easy it is to add a widget to your interface using Streamlit, right? So Streamlit has an extensive API library, and I've just thrown some light on a few of the most popular elements that you could use. So there are, as you see, st.button. So st is basically like an acronym for Streamlit. So once you import the model, import Streamlit in your environment, you could just have access to all these different components, and using these components, you can create a powerful web app for your model. Right, so it supports media elements, like you can add in images, videos, audios, and you can display data, charts. You can create interesting layouts for your web app. And if you're interested, and if you're really good at HTML and CSS, you can actually create your own components and contribute to the Streamlit component library. So now let's get our hands dirty by doing some demo. So to run your own Streamlit application, you would just need these couple of components that are listed on this slide here. So once you have all these things up and running, just go ahead and clone the customer churn app Streamlit GitHub repository in your environment, and you would have all the files that you need to run your Streamlit app, right? So just give a little bit focus on the pip file and pipfile.log. So these are the two files that will help you install the dependencies that are required to run the application. So to install your dependencies, you just have to run these two commands. First command is to install the pipenv library. This library helps you create a virtual environment. And because we already have our dependencies saved in our pip file, you just have to run the second command, which will automatically create a virtual environment for you and install all these dependencies and create a snapshot. And all you have to do is just enter the virtual environment and start running your Streamlit app. So now we have our, once you finish doing this and your dependencies are set, go ahead and open the Streamlit underscore app.py. Now this entire script defines the application layout, the different UI components, and also the backend logic that's going to be triggered when you're going to play with certain components. So let's have a look at the script. So as you can see, I have imported Pickle here, of course, because we would be needing Pickle to load our model file. And this model file, as you remember from the previous slide, this has both the dictionary vectorizer and the model. And once we have loaded this in our environment, we're going to import Streamlit. As it has already been installed, this should not cause any problem. So you import Streamlit, pandas, and pill, and then we have defined the entire app logic inside the main function here. So as you can see, we have used the st.image to render some images to make our app a little bit more interesting, and then I've added a sidebar from the Streamlit library, which gives you gives your app some layers. So it's like a interactive vertical collapsible bar, which will basically give two options to the users to get their prediction scores. So they could either go with an online way, which is to manually enter the data and get the prediction score for one customer. And if they're interested and they want to do send in a batch of customers, customer data, and then they could go for the batch option. They just click on that, and our Streamlit application could handle these two different filters and basically give a dynamic UI when any of this is chosen. So as you can see, with just a simple if statement, right, if the client selects this, then we've written an entire logic, like basically the layout would look something like this, which has a lot of these input widgets called select box. So select box is basically like a drop down box, and we have given two options for the user to select from. And like that, for every feature that we need, that our model needs, we have given input widgets, and we have also used a number input. This handles number values, so you can give a maximum and a minimum value, and it will trigger a warning if it goes beyond these thresholds. And once we have all the data from the customer, it would from the user rather, it would just take all of it and package it as a Python dictionary. And this dictionary then could be passed into our model. Now the fun part here is the model has been defined under the predict button. So we have used Streamlit's button API to create a predict button on our interface. So if a user clicks on this, only then our a feature, the data is going to be sent into the dictionary vectorizer for it to be transformed, and then it's going to be passed into the model to get the output scores and a Boolean value if the customer is churned or not based on the threshold that we have defined. And both of these are going to be returned and displayed as a success message using st.success API. Right? So similarly, if you want to dynamically change the UI, it's as simple as just adding an if statement here. Under the batch, we're just given a file uploader option. This would just create a widget where users can give CSVs, upload CSVs, and once the CSV is received, then it can check for it, and pandas could handle the reading of the CSV part, and we have the same model scoring logic here as well, right? So this is our simple stream app script, and let's go ahead and see how we can Dockerize the script, right? So we have all our model dependencies and our Streamlit application ready. And to publish this Streamlit app, we're going to use Docker. And first we have to write a Dockerfile. So Dockerfile is going to create a snapshot of the environment in which you're going to run the app, and then this snapshot is then going to be used to create a container, and your model is going to run within this environment. So we're going to start off with just importing a very simple, minimal Python Slim 3.8 version image, and that is going to act as a base environment. And on top of that, we're going to upgrade our pip library. We're going to add a working directory called app. And inside that, we're going to copy all of our code and dependencies into the Docker environment, right? And once we've copied all of that, we are going to install our dependencies, which are mentioned in the requirements.txt file. So this requirements.txt file will have all the libraries like pandas, scikit-learn, streamlit, and all of that. And it's going to go ahead and install it on our in our Docker environment, and then we're going to expose a certain port, 8501. Just for example, this means that our application is going to be listening on this port for any requests. And to make our image executable, we have added an entry point, right? So to run a Streamlit application, the command is basically streamlit run stream underscore app, whatever Python script that we've written, right? So we're going to add this as a command. And once we have written the script, basically once we've written this Docker file, all that's left to do is build and run the Docker container. So the Docker build command, the first command, is going to create a Docker image for us, and the image is going to be called customer churn. So the customer churn image, after it's created, you could just publish it on a particular port that you like and map it to 8501, because that's the port that we've defined for a Streamlit application to be running on. Map your host port to your container port using the -p option, and then run the container in a detached mode. And let's see how our Streamlit application looks like. So as you can see, we have run the customer churn image that we have just built, and I've published it on the 8500 port on our local machine. So our container is now running in the detached mode, and let's access this through our browser using localhost 8500. So there we go. We have our Churn prediction app deployed on localhost, that is our host machine on the 8500 port, and it's being run using Docker. And as you can see, we have this vertical collapsible bar, which was made using the sidebar API, and it has two options, online and batch. So let's look at the online one. We have all these drop down boxes for the different data points, um, and as you can see, we can enter some information here. The application would just take it, receive it in the backend, process it as a Python dictionary, and then once we click on the predict button, it's going to return us with the churn probabilities. Well, usually it's not going to be this slow. It's pretty slow because my CPU is kind of burning with other applications. But here you go. The risk score is 0.21, so it's pretty low. So that's why we've said this, that the churn is false. This person might not churn. So yeah, there we go. We have the batch option as well. So let's have a look at that. So as you can see, we have an extremely good looking user interface which was just created using simple minimal code from Streamlit, and now you can drop in CSVs and get a prediction in return as well. So there you go. We have built the application, Dockerized it, and then we have accessed the application using our browser through an endpoint, and that's all, guys. That's how simple it is to develop and deploy a machine learning model using Streamlit and Docker. And if you're interested to get a deeper understanding of how it was done, please check out the blog, and the source code is available on on this GitHub repository. Please go and clone, and happy coding. Thank you.